In this demonstration, we're going to test the Rosemont 3051 pressure transmitter with an input range of 0 to 200 inches of water while verifying the milliamp output range of 4 to 20 milliamps. Connect the test leads from the output of the 719 to the power connections on the transmitter. Then, make a pneumatic connection between the input of the transmitter to the output of the 719. Power up the transmitter with the loop power supply. We'll measure the milliamp signal drawn from the power supply that is provided by the 719. Initially, we see the milliamp signal being measured and the pressure that's being applied. In the first step, we want to measure 0 inches of water. The best way to do this is to vent the atmosphere. We do that with these controls. Open the vent valve. The vent valve can be opened or closed. Open for measuring the 0 inches of water point. This pressure vacuum switch allows you to pump either positive pressure or negative pressure. For this example, we're going to measure positive pressure. First, we apply 0 inches of water. Measure 4 milliamps. Any deviation from 4 milliamps is calibration error. Next, close the vent valve. The next test point, 50%, is 100 inches of water. We'll use the electric pump to generate 100 inches of pressure. Once the 719 gets close, you can use a vernier to adjust exactly 100 inches of water and verify for 12 milliamps. Any deviation from 12 milliamps being measured is calibration error in the transmitter. The last step is to test the full-scale pressure value of the transmitter, 200 inches of water. Use the electric pump to generate 200 inches of pressure. Use the fine adjust in the pump to dial in the value to exactly 200 inches and verify for 20 milliamps. With 200 inches of water applied, the deviation between measured milliamp value and 20 milliamps is the calibration error of the transmitter. In this example, we're going to test a pressure switch by measuring the de-energized contacts of the switch with the 719 while applying pressure to the input of the switch from the output of the 719. This switch has a set point of about 10 psi. Connect the pressure and verify that the vent controls are in the closed position and set for positive pressure. Enter the switch test mode. Switch state initially is closed. Apply pressure to the switch with the electric pump and wait for the contacts to open. The contacts open, indicating a state change in the switch. Let the pressure out and wait for the contacts to close. The test is complete. Press Switch Test to recall where the contacts open, where the contacts close, and the size of the deadband for the switch. In this example, we have the 719 milliamp output connected on the input of the PLC. We'll drive the milliamp signal from the output of the 719 into the PLC, which then produces an output signal to drive a local indicator. By sourcing a milliamp signal, we can test the input of the PLC, the output of the PLC, and the local controller. To perform this test, toggle the milliamp output mode to source. In milliamp source mode, the 719 is outputting a milliamp signal, being measured by the PLC. Percent of span is indicated by the analog indicator. To change the milliamp output, press the 25% step button and you can test the indicator and the PLC in 25% steps. The 719 has a milliamp loop calibrator built in that can be used for testing 4 to 20 milliamp I/O. In this example, we have the output of the 719 connected to the input of the PLC. The PLC output then drives the local indicator. So by sourcing a milliamp signal, we can drive the PLC, check for an indication, drive the output, and look for a local indication. To enact milliamp output mode, change the milliamp output to source, and you'll see we're sourcing 4 milliamps. The PLC is measuring 4 milliamps and 0% of span, and the local indicator shows 0%. Press the 25% step button to increment the output in 25% steps. You can see 4 milliamps, 8 milliamps on the indicator, and 25% on the PLC. Again, advance to 50%, 75%, and then 100%. To make small adjustments in milliamps, use the up and down arrows to change the output in small increments. One key feature of the 719 pressure calibrator and our 718 pressure calibrators is the cleanable pump. In the event that you catch fluid inside the unit, you can open up the cleanout valves in the bottom of the 719 and remove the fluids. You'll need a slotted screwdriver to access the cleanouts and a cotton swab to clean out the chambers. Use a good level workplace where you can capture the small parts. The removed parts include the check valve, the tensioning spring, and the cover screw. Once you've removed the small parts, clean out the chambers with a cotton swab to remove the fluids. To clean out the chamber, insert the Q-tip and rotate to clean out the fluid and then remove. To reinstall, first install the check valve with the rubber gasket side down into the chamber. Next, install the spring. And last, install the cover. Tighten until snug. Fluke Process Tools, keeping your process up and running.